So as I told you, this part here, you guys are able to see the screen, right? Guys, you're able to see the screen? The blue box?
Yes, sir.
So as I told you, this part where do you see as the blue box in which I highlight, it doesn't have any movement. The reason being the opening on the left and the opening on the right being on the top level. Take considering this as a building and the human activity factor, which is around a person's normal height is on average to 5.5 to 6 feet. So 1.8 meters. So the habitable space doesn't get any breeze or wind movement at all. Whereas in this example, what you see is there's going to be a big opening here and a much more smaller, comparatively a smaller opening on it's almost the same size. So this opening gives you a perfect example of what is a perfect condition which you can bring in a cross ventilation. This is all in section. So understand this part here. The human activity center as an activity level gets well ventilated. Okay. And this is another example where there's an opening on the left is at the top and the exit as at the bottom. So how this is going to go about? The air movement takes from the top, and because the openings at the bottom, it is to force itself to come down and leave. But again, it leaves a void here. So these are different conditions and different scenarios. We might, at times, we have to use all of these conditions. Also, I would definitely won't say that only there's one particular condition which is right. There is a variation also. And here, if you see, there's a very big opening on the left side and a smaller opening on the right. This also works in a good portion. So these are the ways in which the cross ventilation can be achieved. And coming into the particular, now we spoke about cross ventilation. Now, what is the effect of window positioning? The reason is, do you see this plan here? In this plan, do you see your triangles here? The great triangle? Guys?
Yes, sir.
Can someone guess what it could be? Is it a part of the building? It says it's a plan, but does it have any significance here? Why don't you guys give it a shot and give it a try? There's nothing, I'm not going to mark you whether you're going to say a wrong answer. So this part, the triangle here, is called the wind shadow. Remember this drawing, what we saw, how the wind shadow. So this is a wall here on the plan, and this is a smaller wall. So there's going to be a wind coming from this side, from the left to right. And what happens is, because this surface doesn't have any openings, obviously the wind will go to a bigger conical action here and a bigger conical action here. And in this, a smaller wall. So the wind will go on a smaller part here and a smaller part here. The gray factor is just a wind shadow part. So because of this particular orientation, the wind entering into the building takes a direction. It takes a very peculiar 45-degree angle and then goes into the opening. Do you guys understand this part? This is quite critical for you to understand. Do you understand what's the logic behind this? Because the wall size is longer and doesn't have any opening, there's a bigger wind shadow formed here and a smaller wind shadow formed here. Because of this particular reason, there's a direction in which the airflow takes a path. Similarly, if on a section, this would be the much more appropriate one. In a section, normally we'll have a building at this, the windows at the sill level. And here, you can see, because from the ground till the sill, it's going to be a wall. There's going to be a bigger wind shadow region. And on the top part is a smaller triangle. And because of this, the wind direction will obviously take a rise up. Probably if we have an equal length of window, as in like the window height from the top to the bottom, then we'll have a much more bigger. So that's a perfect thing what they are shown here. What they're given a comparison here is Because you have a smaller size, the wind flow obviously goes up. The human activity part doesn't get ventilated. So what is the solution they suggest is, if at all above that part, there's going to be a parapet wall which is coming up, which becomes like a two triangles which are of equal size, which are wind shadows, and the air would come into the human activity part. You guys are able to understand this part, or should I rephrase it or guys? I need to get an acknowledgement to know whether you guys understood. Otherwise, I need to rephrase it and put in a different way. What should I?
Can you rephrase it, sir?
Yes.
I
Okay.
was not
Fine.
quite.
No problem. Not a problem. See, this plan, on a plan here, there's no openings at all, except there's an opening which is given here, and there is an opening which is given here. Okay. This is a solid phase of the best example. Wait, I think I can go to. Do you guys see this drawing here, guys? Remember this? I told you about a box, a building, which doesn't have any openings at all. So what happens in a wind flow? Obviously, the wind gets diverted because there's no wind activity also here. The wind gets diverted because it becomes a high pressure zone and it goes around the building. Okay. And comparatively, if you take an example here in this second part, second drawing, do you think this distance and this distance have a variation? Here, this wind funnel gets on a much more narrower. The reason being is because of the angle of the building, it gets into a much more narrower part. This is the same principle happening. Once if you have a wall without an opening, there's not going to be any air movement. Obviously, it is going to go around it. The same condition is applied here. Just consider this as a one particular part. This particular wall, this as a particular the square building. So when the wind is going to come from here, it is going to converge on both the sides. So it leaves a bigger shadow angle. Whereas this particular part, it's a smaller triangle, a smaller building. If the wind is going to come in on a perpendicular direction, it's going to go on the two sides, which is a smaller shadow angle. You guys are able to relate this now?
Yes, sir.
So this is exactly, as I say, as a blank wall. How a blank wall, we think only a window position makes a difference. But even the blank wall, whatever we call as a sill, we call above the lintel, makes a big difference in the wind flow into the room, into a space. That is what exactly we are speaking here. So on the section also, this is on the plan, this is on the section. What we see is this part is considered as a block, and the ground, obviously. So the wind can go in only in one direction. It's not going to take a triangle like this. It can go only in one direction. So it takes an angle here. This as a smaller triangle, a smaller block. The wind eating through it goes in two directions. So this becomes a smaller triangle. So how this flow is affected. Whereas if I'm going to bring there's no parapet wall on this top example. There's no parapet wall here. But what if I have a parapet wall? Then I'm going to have two equal shadow angles and where my air is going to be diverted downwards. Clear?
Yes, sir.
So this is about similar example of how the air movement happens in a two-story building. If at all you can understand the earlier concept only, you can understand. This is a section again. You can see the wall here, which is a sill level. How the wind shadow is happening here. And here is above the lintel and again the sill level. How this triangle is formed because of this above the lintel's wall and the sill wall. And how the air movement varies in each of it. Again, because here it doesn't take into consideration of the habitable space. So simple solution is bring a parapet wall here. If you have a parapet wall, it's going to again bring in a bigger shadow angle and it's going to divest the air below. Clear? Now size of openings. You guys know what's a Venturi effect? Venturi effect. No. Have you guys used a water hose to either clean something, clean a floor, clean a bike, or water a garden? Have you
Yes,
guys
sir.
used it? A water hose.
Yes, sir.
Okay. So normally in a water hose, you can see as how much of a tap pressure you open up. That's the water you're going to get into your outlet on a water. I'm just saying about the empty pipe, as in like the without any fixtures on the top. I'm not saying about the spray and all. Okay. So manually, what we do is to increase the pressure. What we do, we partially close the opening with the finger. Do you remember doing this?
Yes, sir.
So what happens is you get a much more faster increased pressure and the water flows out into a big funnel. That's exactly is called as a Venturi effect. That's one example of Venturi effect. So what happens is in Venturi effect, when there's going to be a big opening, there are going to be two buildings that are close to each other. So which means they have a very minimal gap between two buildings. The air entering into one side converges, and again, once it opens up, it's going to throw in a bigger rush of air, a bigger volume of air with a minimal pressure. So this pressure is called the Venturi effect, and how this is going to be used up. So normally we say to have a better flow of air, to have an opening, whenever we're going to have an opening in a building, it is suggested on the windward direction, try to have comparatively a smaller opening. I'm not saying very minimalistic, but a smaller opening. And on the leeward side of the building, where the air is going to exit out, have a bigger opening. So what happens is this increases the flow of air volume inside the building and it pushes out. So this is what would have been mentioned. This is what has been mentioned here in this whole part. If at all the same topic, if you look into the point 4.3.12 size of openings in the book which I've given you, please read it. You will find the same content present there. As in, what is the explanation which I given now? So this is about sashes. Sashes are nothing but vertical openings. Vertical openings or horizontal openings are called sashes. And there are another things about louvers. Canopies are nothing but the shades, water shades. So the example here mentions, if at all you have an angled sash, one with a top hung. This particular opening is called a top hung. The reason is it is connected. It is connected at the top and it can move open out inwards. So the wind flow will obviously take in this part. Again, you can see the triangle here, the wind shadow, and how the air movement goes in. Here, in this, you don't have a connectivity on the top, rather a connectivity on the bottom. This is called pivotal. It's called a center pivot. So this pivotal would obviously, because the inclination is here, it would throw in your air towards it directly makes it flow through the habitable space. Now with respect to the canopies, because of the canopy, do you notice a big difference here? There is no wind shadow formed here. Technically, if this canopy is not here, there would have been a triangle formed here, which is a wind shadow. But because there is a canopy, there is no wind shadow formed and how this airflow takes part. Now to better this whole aspect, it is suggested that you give a space in between the canopy. As in you have a canopy connected to the building, but there is going to be a space on the top, which means it's going to obviously force its air pressure downwards and take it up. So this is what are the two examples. This is with the Venetian blind and louvers. Louvers are nothing but what you see in a toilet ventilator, what you see as stacks of glasses put up. So these can be used as for ventilation also, depending on what angle of inclination and what is the direction of inclination. Similarly for the Venetian blinds. So this is another part. This, okay. So with this, yes, we are done with the, except for the software simulation for wind and air movement, we are solar movement. We have completed almost the second unit now, second cycle. You guys have any queries on this? Please ask. Something which you didn't understand, or something you still trying to find it's difficult to figure out. Any of the contents from your guys? There's no acknowledgement. Yes or no? Anything? Any queries? Why don't you post tell your queries? I can try to sort it out. Help you guys out with this. See, these are basically principles. You don't really need to know about formulas, calculations as of now, anything at all. This is a pure application of physics. This is just physics on how things work. That's why whenever I quote you examples of, with simple examples like the pipe and the tumbler with water. If at all you have doubts, why don't you try the experiments now? You being at home, why don't you try immersing a empty glass, perpendicular to the surface of the water? See what happens. Because of the trapped air, you won't be able to do it. Even if you do it, the water won't get into the vessel. So that is a part of the understanding of stack effect, how a pressure can be relieved or not. Is there any queries, anything? I'll be posting the video, the earlier videos and today's video sooner. I've done uploading the videos, so I'll get you all. And meanwhile, I'll share the notes also. See, this notes what I've compiled is the exact content what is picked up from the Manual of Tropical Housing book. So I've already given you the book. You can refer the book if at all you need to know what is the exact sequence. Look into the topics available there. Otherwise, I'll give you this part also. You can have this as for a reading. Okay. So can we get done with the class?